So let's now discuss a very important topic. Okay, I don't know whether it is important or not, but yeah, well, a very interesting topic at least I can say, which is the rank and eigenvalues relation. Okay. So what do you think? Like, I mean, before I go further, what do you think whether there could be a relation between rank and eigenvalues, or there will not be any relation? Just think about it. See, I know one thing that is for sure, that if eigenvalue is 0, okay, then it definitely means that the determinant is 0, which means that rank is not equal to n, right? So it is not a full rank matrix. So rank of A is less than n, that is for sure. But can I definitely say that if eigenvalue is 0, then can I definitely say that rank of n is n minus 1 or n minus 2 or n minus 3, something like this? Can I say like this? So the answer is, to be honest, no. Okay. Like, if someone asks me that what is the relation between rank and eigenvalues, I will say that honestly there is nothing, not at all relation, like between the rank and eigenvalues. The only relation that we have between these two is when, like, I mean, if eigenvalue is 0, if eigenvalue, okay, is 0, then only there is some relation. And if eigenvalue is non-zero, then the rank, if eigenvalue is non-zero, okay, so this is EV, means eigenvalue is non-zero, then rank definitely is n. Okay, then it is full rank matrix. If eigenvalue is 0, then rank is less than n, and you don't know that what is the rank. Maybe n minus 1, maybe n minus 2, maybe n minus 3, like that. So in summary, you can say if eigenvalue is not 0, then rank is definitely n. If all the eigenvalues are non-zero, then rank is definitely n. If all the eigenvalues are non-zero, then rank is definitely n. If any one of them is 0, then rank is less than n for sure. Now here, interestingly, you cannot say that the rank will be n minus 1 or n minus 2 or n minus 3 or like that, right? So you cannot say anything about it. If someone says that, okay, eigenvalue of A is 0, then you don't know whether the rank will be exactly n minus 1 or n minus 2 or something like that, right? I mean, in some cases we can say, so that's where we will do some questions. But I hope the overall idea is clear to everyone. Okay, now let's just do some questions. So anyway, this is the flow chart where I'm saying if eigenvalue of A is not 0, then rank is definitely n. In that case, I don't have to worry, because if all the eigenvalues are non-zero, then determinant is non-zero. Determinant is non-zero means it is full rank matrix. If eigenvalue is 0, then determinant is 0, it means it is not a full rank matrix. Very, very easy, right? Okay. So here you can see that number of linearly independent vectors corresponding to 0 equal to k. If that's the case, then free variable will be k, and then rank is n minus k. So what is this line? Let me just clarify. Okay, see, I have a minus lambda I. I mean, I do solve a minus lambda I into x equal to 0 if I am solving for eigenvector. Do you remember? And then let's take two equations, ax equal to 0 and a minus lambda equal to 0, lambda into x equal to 0. So these are two different, okay, two completely different set of homogeneous equations, This is the set of equations that you got when you solve for eigenvectors corresponding to lambda. This is any general ax equal to 0, right? So these are the two completely different set of equations. I can say that these two set of equations, right? So this is one set of equations, and this is another set of equations. Now these two equations are actually similar only when lambda equal to 0, right? So if lambda equal to 0, then both are similar. If lambda equal to 0, which means if I'm talking about lambda equal to 0, then you are actually solving ax equal to 0, right? So basically, if someone give you something about ax equal to 0, then and then they also say that, okay, one of the lambda is 0, then you can infer about something about a minus lambda into x equal to 0. So okay, let me just tell you, don't worry, like we will go very slowly, we will understand this very clearly. See, what do I mean by that? Let's suppose, okay, before that I will ask you one question, and you just need to answer me. Suppose I say ax equal to 0, I'm just solving for ax equal to 0, okay? Now here I'm saying that this ax equal to 0 may have non-trivial solution also. I mean, trivially, obviously it have x equal to 0, but it may also have the non-trivial solution. Suppose it has the non-trivial solution, okay, which means that x is trivially 0, that is okay. Now tell me, if it is having a non-trivial solution, can the non-trivial solution be unique? Can ax equal to 0 have a unique non-trivial solution? Can it be the case? Which means that, see, there is only one non-trivial solution. Can it exist? Can I say something like this? Answer is no. Answer is no. There are many reasons behind it. Just think about it. Why it is no? Just pause this video and think about it. Why it is no? Which means if the non-trivial solution exists, then there has to be infinitely many. Why? Because see, x equal to 0 is just one solution. If, which is a trivial solution. If let's suppose one more solution exists, where x is non-zero, okay? One more solution where x is not 0. Then these are the two solutions that you have. So either you have the unique solution or infinite solution. You cannot have just two solutions, right? So if x is not equal to 0 exists, then there must be many x not equal to 0. If it is non-trivial, then it cannot be just one for x equal to 0. Because already x equal to 0 is one solution. Let's suppose if it is not there, x equal to 0 equal to solution is not there, then yes, one unique solution is could also exist. Because see, number of the solutions could either be unique or infinite. Now unique is already there. The one solution is already there. If you just saying that one more you have, it means you have infinite, right? Or in other words, you can understand like this. Maybe see that. Okay, you can understand like this, that let's suppose there is a non-trivial solution, okay, which is giving you 0, which means that some combination is giving you 0, right? C and Vn, some combination is giving you 0. And now you are saying that this is non-trivial, which means like one of the Ci is non-zero. Now, can you have one more solution which is giving you 0? Yes. See, that's extremely easy to think about it. If you have one solution which is 0, which is looking like this, C1, C2, Cn, which is giving you 0. Do you just have one solution? No. You have 2C1, you have 2C2, right? You just multiply by 2. That is also giving you 0, right? There are always infinitely many solutions. You have 3C1, you have 3C2, like that, right? So basically, there is always infinitely many solutions for this. If there is at least one Ci which is non-zero. If all are zeros, let's suppose only trivial solutions, then even if you multiply 2, actually it will be just boiling down to 0, 0, 0, right? So that's why it is not much useful. But yeah, if there is at least one non-trivial solution, you are having infinitely many non-trivial solutions. Okay. I hope that is clear to everyone. Now, why I'm telling you this story here is because let's just now connect this story to a minus lambda I into x equal to 0. Do you remember I told you once that if you are solving this kind of equation, then you always have at least one free variable. See, it doesn't matter what is the value of lambda. Whenever you are solving this equation, you always have one free variable, at least one free variable. Why? Because the way we have constructed this a minus lambda I already know the determinant of a minus lambda is actually 0. If determinant is 0, it means there must be one free variable. And it means that there are always infinitely many eigenvectors. There cannot be just one eigenvector, right? There cannot be just one eigenvector. So basically, for this kind of equation, we already know there will be at least, right, irrespective of value of lambda, there are always at least one free variable, right? You can just say there is always at least one free variable. It means what? It means there is always at least one free variable. It means that there are always infinitely many eigenvectors. Okay. So corresponding to any lambda, there is at least one free variable always. Okay, cool. Now if lambda is equal to 0, then as we know that there will be at least one free variable, right? So there will be at least one free variable. That is always the case, right? Now suppose they say that there is exactly one, or there, I mean they give you the number. Let's suppose they say there are two free variables. Okay, suppose they say as a question that there are two free variables in ax equal to 0 solution. Suppose they say that there are two free variables in ax equal to 0 solution. Then can you talk about the rank of A? Let's suppose A is 10 cross 10 matrix. Then what will be the rank of A? See, they are saying that there are two free variables. Whenever you are solving ax equal to 0, actually equal to 0 does not matter, but yeah, whenever you are solving x equal to 0, you got two free variables there. Then what does this mean? It definitely mean that the rank is, or the nullity, you can definitely find out the nullity, which means nullity is 2 and the rank is 8, right? Because you got two free variables when you are solving x equal to 0 in the matrix A, you got two free variables, right? Which means let's suppose these are the two free variables, and A is a square matrix. So here I am talking about only a square matrices. So A is a square matrix, you got two free variables. It means what? Nullity is 2, or in other words, rank is 10 minus 2, which is 8. Okay, so if you can solve this question, then probably you can solve some other question also, which is related to eigenvalue. See, currently I have not introduced eigenvalue in this particular question, but I can easily introduce eigenvalue just by changing this language. See, I will ask you the exact same question, but with a different language. Let me just try, okay? And then you might get confused. See, there are two free variables corresponding to, okay, so instead of writing all of this, there are two free variables when solving a minus lambda I into x equal to 0 corresponding to lambda equal to 0. Then what will be the rank? This is what I'm asking. See, earlier they have given you directly that, okay, ax equal to 0 has these many free variables. Now instead of saying ax equal to 0, I am saying a minus lambda equal to lambda into ax equal to 0 and lambda is 0, which means I am talking about ax equal to 0 only, right? I am saying when you are solving ax equal to 0, you got two free variables, right? Then there are two free variables corresponding to a minus lambda into x equal to 0. When solving a minus lambda into x equal to 0 corresponding to lambda equal to 0, then what will the rank? Again, actually this is just ax equal to 0. Then what will the rank? In that case, the rank will be, and basically if they have given you this information, they have given you the nullity, right? Which means the nullity is 2, so rank will be 8. So I hope you are getting what I mean to say. See, if they say that lambda equal to 0, then what is the rank? Then you will say rank is less than, let's suppose A is 10 cross 10, okay? Rank is less than 10. You will say something like this. Then they say, okay, no problem, lambda equal to 0 and number of free variables also they are saying. Okay, I will make it little more interesting, but currently number of free variables when solving for a minus lambda I into x equal to 0 corresponding to lambda equal to 0. If they R2, okay, R2, then if they give you this much information, which means if lambda equal to 0 only they give you, then you will say, okay, rank is less than 10. And then if they say, okay, lambda equal to 0 and also the number of free variables corresponding to lambda equal to 0 is 2, which means the nullity is 2, which means basically whenever you are solving this, you got two free variables, right? You got two free variables whenever you are solving this. See, you got two free variables. And this is just ax equal to 0. If you get ax equal to 0 whenever you get two free variables, it means that there are two linearly dependent columns in A. It must mean if there are two linearly dependent columns in A, it must mean the rank is 10 minus 2 equal to 8. There are 8 pivot columns, it must mean, right? I hope you are little understanding. I'm not expecting you to understand everything in one go. So let me just ask one more question. They say the lambda equal to 0, that is fine, and they say that number of this is very interesting, linearly independent eigenvectors for lambda equal to 0 are 2. Then using this information, can you tell me the rank? Okay, A is again 10 cross 10. Can you tell me the rank? Just think about it. See, they are saying that lambda equal to 0 and number of linearly independent eigenvectors. See, how you calculate the eigenvectors? You calculate using this equation and you got the solution. See, eigenvector is just a solution of this, right? Let's just do step by step. So solution of this means you are talking about lambda equal to 0. So you are talking about solution of this. So x is a solution of this. See, x earlier, just now take a pause and just listen to me here. Earlier x was just a random vector when you are talking about ax equal to 0, and then you are saying that okay, can you find the solution for ax equal to 0? It is a solution that gives you x equal to 0. That is fine. But now if I'm coming from here, if I'm coming from the top, which means I was about to solve a minus lambda I into x equal to 0, but I got the information that okay, ax equal to 0, I mean by putting the lambda, then I call this as an eigenvector. Okay, not just a normal vector, eigenvector. So basically here also I'm talking about the solution of x equal to 0, but here x is an eigenvector. Okay, now they have given that number of linearly independent eigenvectors are just 2, which means if you solve this, then x you will be getting 2, I mean s plus t, which means number of the free variables they have given indirectly in A, which are 2, which means they are talking about the rank is again 8. Are you getting my point? So basically, if they give you number of linearly independent eigenvectors corresponding to lambda equal to 0, it means they are talking about the nullity. This is same as nullity. Basically, this lambda equal to 0 is a connecting dot between a minus lambda I equal to 0, between a minus lambda I, okay, into x equal to 0, and between ax equal to 0. So between these two, the connecting line goes through lambda equal to 0. Okay, I hope you understood. So basically it's very easy. Like whenever they give you any information about lambda equal to 0, you just try to convert that information. Just think in terms of ax equal to 0. They are saying that okay, you have two linearly independent eigenvectors corresponding to lambda equal to 0. It means they are talking about solutions of ax equal to 0. You have, okay, if in other words, if I just ask you that okay, in the solution of ax equal to 0, you have let's suppose if I ask you that solution, let's suppose this is one question, okay, this is one question, then I'm saying solution of ax equal to 0 looks like following. X equal to s into something plus t into something. So suppose something like this, right? I say that solution of x equal to 0 looks like following. Then can you tell me about rank of A? If A is 10 cross 10, just think about it. We have solved GATE 2021 question, right? GATE 2021 question, exact same question, exact same. There is no difference at all. There they have just given, instead of this two, I mean the number was changed, right? They have just given one vector. I think we have solved this question, and there you immediately told me that answer is 8 or there whatever is the answer. I think 4 was the answer there, right? So basically we have already solved this kind of question. Now I'm just rephrasing that question and putting, instead of directly giving you x equal to 0, just putting one more layer above it. I'm saying lambda equal to 0, and you talk about a minus lambda into x equal to 0. And instead of x, I'm saying it is eigenvector. Instead of general vector, I'm saying it is eigenvector. Basically, I'm just connecting these two just using lambda equal to 0. See, that's what they have said. They have said that corresponding to lambda equal to 0, number of linearly independent eigenvectors are 2. It means what? That if you solve for a minus lambda into x equal to 0 corresponding to lambda equal to 0, which means you solve those ax equal to 0, you get 2 linearly independent eigenvectors, right? Which means that x looks like this. It means that rank is 10 minus 2, 8. That's what the exact same question that we did. Are you connecting the dots? I hope you are getting me, right? So let's just do one thing. Let's just do more questions. Maybe probably after that you will get to understand it a bit more clearly, right? Okay. So this is one statement. Let's just read this out and let's just do more questions. So what they're saying, if each of the n eigenvalues is non-zero, then matrix is full rank. Yes, that's what we have seen. See, if all the eigenvalues are non-zero, then it is full rank. If one of the eigenvalues is 0, then the rank will be less than n. That is for sure. And how much less? That's what we need to talk about. Okay, I mean, using the questions, let's just observe some pattern that can we exactly tell what is the rank or we cannot tell. Okay. And now there are 1, 2, 3, 4, 5, 6, 7, right? So there are 7 or 8 questions, which most of the questions I have made, and one question I have taken from Berkeley University. So just try out these questions, okay? And then we will be solving these questions in the next video. So it is interesting question. These are the very interesting question. Most probably you will not be able to solve it. Like, sorry for that. Reason being is that I need to explain maybe these questions, because these questions are quite nice. So I will be explaining, don't worry, but just give it a try. I will put those questions in the slide, and then I will put these questions one more time, which means for this video I will put it separately, and then I will add these questions again for the next video, so that you get the clear picture. You don't get the annotated questions. Okay. Yeah. Thank you so much.